look at simplifying rational exponents with variable bases. So when we look at something like this, and I ask you a question, we're going to use our exponent rules just as we would if they were just integer exponents. So if I give you something like this, I know the rule for multiplying like bases is to add my exponents. And so if I look at this, I know, oh, wait a minute, I need common denominators before I can add fractions. So I would rewrite this problem. And the LCD is 10 for each of these. So this one didn't change at all, so that top does not change. This bottom you had to multiply by 2, so you have to multiply the top by 2. You should get 4/10. Now they're broke up into the same amount of slices if you're looking at it in fraction form. Now, like bases, I add my exponents. I should end up with x to the, add your tops, x to the 5/10. But I wouldn't give that as my answer. You always want to write it in reduced fraction form. So I would actually say x to the 1/2. Now, it wouldn't be incorrect if you wrote that as also the square root of x, because power over index, but I'm not asking for you to write it in simplified radical form, so that's as far as you have to go. The rule is always also going to say write with non-negative, write your answer with non-negative exponents. And so positive exponents, or exponent of 0, so non-negative exponents. So now let's look at another problem like this. So this isn't so bad, you know, like bases. I could do a quotient problem. I would subtract my exponents. But let's look at one where it's power to power. So if I have something like this, I know power to power, I have to distribute, multiply that through to every exponent, because it's actually, all these have an exponent in them, or a power, and so you have to multiply it through to every single exponent. So I'm going to end up with this first. My first step would be 2 to the negative 4, x to the, if you multiply 3/4 times negative 4 off to the side, your 4's will cancel and you should end up with a negative 3. And then if you multiply negative 1/8 times negative 4, you're going to get a positive 1/2. So you can try that off to the side. So that would not be my final answer, because my answer has to be written with non-negative exponents. So then I would simplify this down, get rid of my negative exponents. Think of this as a fraction. Send any base that has a negative exponent down to the denominator, and the exponent becomes positive. So I'll end up with y to the 1/2. If I send 2 to the 4th down here, and this one is going to be x to the 3rd, positive 3 now. Y to the 1/2 stayed on top, so a positive exponent. But if you ever have a number base brought to an exponent, we'd like to see you simplify it all the way down. 2 to the 4th is actually 16. So your final answer for that, the answer you'd see in the book, is just going to be y to the 1/2 all over 16 x to the 3rd. And you're finished, because the directions didn't say you had to write that in simplified radical form. It just says non-negative exponents. It's simplified all the way down. I didn't have one on here. I can show you a quotient one. We can make one up really quickly. So we'll do that. We'll do the same problem, but let's go like this, and let's go x to the 1/10. So now I have a quotient problem. Well, I know that it's top exponent minus bottom exponent. So I have to write them with the same denominator so that I can subtract them. So this would be x to the 4/10 all over x to the 1/10. Now, top exponent minus bottom exponent, 4 minus 1 is going to be x to the 3/10. Positive exponent already, so I don't have to send it down to the denominator. So that's using your quotient, using your exponent rules, but these are fractional exponents or rational exponents, and so same rules that you've done in the past. And so practice with those, and we have to hit on these because sometimes we'll be switching forms from radical to exponential and back and forth to help us solve problems. So.